host, right? Okay. Read-only memory or ROM is also a form of data storage that can be easily altered or reprogrammed. It stores instructions that are not necessary for rebooting up to make the computer operate when it is switched off. They are hardware. That means the ROM memory are hardware. That means you cannot program, right? You cannot erase the content that is inside the ROM normally. RAM, however, on the other hand, random access memory or RAM of data storage that can be accessed randomly at any time in order and from any physical location on the computer, allowing quick access and manipulation. That means inside the RAM you have some memory, you have some data, you can access those data from any physical location at any moment from the computer. This allow you to quick access and manipulate. Okay. And it stands for the ROM stands for read-only memory. R stands for random access memory. All of you know that. Use the ROM stores the program required to initially boot the computer. It only allows reading. RAM allows the computer to read the data quickly to run application. It allows reading and writing. Volatility. The ROM is non-volatile. That is, its contents are retained. Retained means থেকে যাবে। এটা content মানে এটা মেমোরিতে যা থাকবে এটা থেকে যাবে। Its contents are retained even when the device is powered off. Okay. RAM is volatile. That means its contents are lost when the device is powered off. That is when there is no all the content that is inside the RAM that will be gone forever. There are three types of RAM. One is PROM, EPROM, EEPROM. There are two types of RAM. Those are static RAM or SRAM and dynamic RAM or DRAM. Remember, the speed of the ROM is slower and the speed of RAM is faster. Okay. Here comes the 6 transistor SRAM cell or 60 SRAM cell design. There are several designs available for SRAM, but here we will talk about 60 SRAM. Okay, that means 6 transistor SRAM cell. Here you can see in the SRAM cell you have 6 transistors. You have one here, you have another here, you have two here, PMOS and NMOS. You have two here as well, PMOS and NMOS. Okay. So SRAM is a type of semiconductor memory. Remember, this is semiconductor memory because MOSFETs are used, right? Semiconductor memory that's bistable latching circuitry to store each bit. Bistable latching circuitry to store each bit. Remember, that means there is a pull. Latching circuit, latching. This this loop is called latching loop or latching circuitry. Bistable. Why it is called bistable? Because 0 here, this is 1 becomes 0, 0 become 1 becomes 0, 0 become 1. So there is a loop, right? So this is a bistable latching circuitry. In this, the data will be stored. Okay. And the basic 60 SRAM cell has 6 transistors. Remember. So this is the explanation or detailed diagram of the previous one. They are actually the same. Here you can see you have 6 transistors. One is here, 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 here. 6. Now, how you will write and read from here? Okay. The for write operation, let's say you want to store a 1. You want to store a, so what do? You will give data is equal to 1 here or 0 if you want to store a 0. The data bar should be 0 because it is data bar, right? It is data bar. So if data is 1, data bar should be 0. If data is 0, data bar should be 1, right? That's why it is called data bar. There is a bar. Okay. Next, you have to select the 1. Select means this thing should be 1. If you do not select this thing, what will happen? This 1 will not go inside because the NMOS is, this 0 will not go inside because the NMOS is off. Once once you give 1 here, what will happen? This NMOS will be on. This NMOS will be on because there is 1 here, here and here. So this data will go inside. This 0 will go inside. So what happened? Here you will have 1. Here you will have 0. After that, you will deselect the select line. That means you will give 0 here. Once you give 0 here, this NMOS will be off so that no data can go inside, no data can come out. Okay. So that will remain there. That is the read operation. That is the write operation. Now come to the write operation, read operation. For read operation, there is a small trick. The trick, you have to give 1 here, you have to give 1 here forcefully. See, you have to give both of them 1. If you give both of them 1, that means no ones and no zeros pair will be there. So see, if there is 1 inside previously, so this is 0 previously, what will happen? Whenever you use this, what happened? Here you have 1, here you have 1. So there will be no current flow in this section, right? But there is a current flow in this section because this is 1, this is 0. So a current will try to flow in this way. So the memory controller will, or the memory reader will detect that, and it will give you a decision that it was 1. Previously, the store was 1. The 1 was stored. Okay. So this is the read operation. In the simulation, you cannot read. In the simulation, it is not possible to read. In our simulation today, we will see the reading operation is not possible inside the simulation, but the write operation is easily possible. So we will go for the write operation. Now, to control, this is one cell only. Of course, inside your RAM, there are millions and millions of cells, right? Millions and billions of cells. That's why this is called gigabyte, right? Gigabyte, not megabyte. The RAMs are in gigabyte form now. So there are millions, millions, billions of what? Cells inside. So, but we will deal with only what? Only few. So to control the rows, so they are normally connected in rows. So 1, 2, 3, 4, and rows. They are formed in column and rows. So to control those rows, we will need a row selection decoder, and we will need column decoder because the cells are arranged in rows and columns. So to control the rows, to select the rows, because this is the selection. Remember, rows are actually your row select. Can you see that row select? So there will be a decoder to select the rows. This is the row selection decoder. This is actually a normal decoder. So when you give 0, 0, this will be active, others will be off. When you give 0, 1, this will be active, others will be off. When you give 1, 0, this will be active, others will be off. When you give 1, 1, this will be active, others will be off. So this is a row selection decoder or normal decoder. If we do a truth table, 0, 0, only 1 is on, others are off. 0, 1, only R1 is on, others are off. 1, 0, only 2 is on, others are off. 1, 1, R3 is on, others are off, right? So if I make a logic expression, row 0 is equal to A bar B bar, row to A bar B, row 2 is equal to A B bar, row 3 will be A B, right? Because that is the expression from the truth table. You know how to convert the truth table to logic expression. Now, if I make a from here, maybe there is a mistake in this circuit. What is the mistake? You can see these connections is not connected anywhere. So there is a mistake in this circuit. Do not follow. follow the expression. So A, B, A bar, B bar. So A bar, B bar will be connected here. A bar, B will be connected here. A, B bar will be connected here, and A, B will be connected here. So that becomes the row selection decoder. Now, if you have more rows, there will be more AND gates and more input A, B, C. See, I have designed these for 4 rows, 0, 1, 2, 3. That's for 2 inputs. If I select 8 rows, more than 4 rows, that means 8 rows, I will be needing 3 input decoder, 3 input. So A, B, C will be there. So this is pretty self-explanatory. Now the column decoder, this circuit is the column decoder. Here you have seen there are 2 MOSFET, 1, 2, one for data line, another for data bar line. So there is a line select, there is one write, there is one data. There are 2, 3, one tri-step. These are called tri-step NOT gate. These are called tri-step NOT gate. There are 2 tri-step NOT gates are there. Tri-step means there is one enable pin. Normal, these are actually, this is a normal NOT gate, not a normal NOT gate. These are actually tri-step. That means there is an enable pin at the top. That means if you give 0 here, they will not behave like a NOT gate. They will not pass. Whether you give 0 or 1 doesn't matter. Here there will be no data. Not a 0, not a 1. No data. That's my point. But if you give 1, then they will pass the data. If it is 0, it will become 1. If it is 1, it will become 0. Then you have data. That means if the data you want to give 0 here, you will give 0 here. Get 1 here, you give 1 here. Okay. Now let's make it. Then we will go for a circuit like this. Okay. 4 into 4 SRAM array. This will be the last lab, SCH. Remember, we do not have to give any lab report for this lab because this lab is not entitled or enlisted in our lab sheet. Okay, this is additional lab. We'll do the additional lab. What is the software? Okay, here. So at first, we will go for the row selection decoder first. Okay, how to do that? See, we need AND gate 2, 3, 4. Next, we need what? We need 2 inputs. One is another one is for, let's say it's B. Then we need NOT gate. One for A, another for B. Okay, let's double click and write A. And we need what? Okay. So this is our A, this is our A bar, this is our B bar, this is our B. The first one will be A bar, B bar, right? A bar, B bar means A bar will go. And the B bar will go. That's it. Next one will be what? A bar B. So A bar will go and B will go. A bar B. A B bar. So the A will go here. So the A will come from this side. And the B bar will go. This is the B bar, right? This is the B bar. Okay. Last one will be B. So the A will come from here. And the B will go like that. Okay, fine. Let's, so 0 0 this is on, 0 1 this is on, 1 0 this is on, and 1 1 this is on. So our that is what is done, right? So Let's delete all the not yet, and we will save it. Let's write row selection decoder, right? Row selection decoder. Let's write it like that. Row selection decoder. RSD. Okay. Now let's go for the next one. Which one is our um, column decoder? Okay, this one. So what do we need? At first, we need to MOSFET. Let's give a gap. The gap should be there because this gap is important. So two MOSFET. Next, we need what? We need one not get. Remember this. We need button. This is our what? This is our line select. Okay. Line. This is our line select. Line. Select the line. Line select. Next one will be what? Next one will be right. So this is our data. This is our data line. Next, we need tri-state not get. Here's the tri-state not get here at the middle one, beside the not get. Let's write it like this. Fine. This one will be connected here. This one will be connected here, and their inputs, the not input, their control line. The control line should be connected with what? The control line should be connected with a P, with an input, right? This one will be what? Right. Whether you want to write it or not, this one. Now this one should be connected with this one, and yeah. That's it. Okay, this is our column decoder. So line select, write, and data. Let's save it. Column selection decoder or column decoder only. CDEC. Okay? CDEC. That is our column decoder. Fine. Remember, I am not saving them as what is that? As symbol, right? I am not saving them as symbol. I am saving them as schematic. So I will be now. Let's go and make one. What is that called? Cell, right? Next, we need what? We need NMOS. Like this. Copy. Like that. this is the data. This is our data bar. This is our line select. Let's check the functionality of this one. Functionality. So if I run, you will see I have to make the data. The data bar should be 0. If I line select, see at first there is no data. There is no data. That's why it is gray. Not blue, not red. It is gray. This is also gray because there is no data. Remember, blue means what? Blue means 0, red means 1, but gray means no data is there. Okay, remember. Now, if I click this will become 1, this will become 0, right? Now it is 1, now it is what? It is 0. If I deselect, you will see now it is not changing anymore, right? The inside data is not changing anymore. Can you see that? Whatever happens outside doesn't matter. The inside data is fixed, right? It is fun, right? Can you see that?
Yes,
Inside the data is safe. So whatever happening outside, no matter because the data is already written and it is safe. So that's why it is a memory. It is called because I am saving a data that is not changing, that is not vanishing, right? Once you turn off the power, let's turn off the power, turn it on. Now you see data is gone, right?
Yes, sir.
Data is gone. So it is RAM, volatile. Okay. Now let's.
একটু রিপিট করেন স্যার।
দেখো আমি যখন এটা রান করলাম এখানে ফার্স্টে আমাকে দিতে হবে 1 কারণ আমি ভিতরটা 1 সেভ করতে চাই। আমি এখানে দিব 0 কারণ আমি এখানটা 0 থাকবে, 0 থাকবে। অপোজিট হতে হবে সবসময়। এখানে 1 এখানে 0, রাইট? কিন্তু এখনো কিন্তু ডাটাটা ভেতরে ঢুকে নাই। দেখো তোমার এই ডাটাটা ভেতরে ঢুকে নাই। সো যখনই আমি এখানে লাইন সিলেক্ট ক্লিক করব তখনই ডাটাটা ভিতরে ঢুকে গেল, তাই না? সাইদুল দেখতে পাচ্ছ?
জি স্যার।
ডাটাটা ভিতরে ঢুকে গেছে। এবার আমি কি করব? এবার আমি এটাকে অফ করে দিব। তার ভিতরে আর ঢুকবে না, বেরো হবে না। এখন বাইরে যদি আমি যতই পরিবর্তন করি না কেন, দেখো ভেতরে ডাটা কিন্তু চেঞ্জ হবে না। চেঞ্জ হবে কি?
না স্যার।
So the data is safe. So that's why it is called a memory. এই জন্য এটাকে মেমোরি বলা হয়। তো এখন তুমি দেখো যদি আমি কি করি, যদি আমি পাওয়ার অফ করে দিই, অফ করে দিলে এই ওয়ান্স আর এই জিরোটা চলে যাবে। দেখো পাওয়ার অফ করে দিলাম, আবার চালু করলাম। নাও দেয়ার ইজ নো ওয়ান, নো জিরো, কোনো ওয়ানও নাই, কোনো জিরোও নাই। RAM পাওয়ার অফ করলে ডাটা চলে যাবে, বুঝতে পারছি?
জি স্যার।
Now I'm going to save the I'm going to save the this version of this one. I'm going to save this version. If we're editing this, we will be editing this version. We have to copy it. Okay. Let's copy it for. Okay, at first insert. Let's insert user symbol, not user symbol. I want user schema, right? Schematic, not symbol, because I didn't make any symbol. Schematic. What? Column decoder. The column decoder. Okay, this is the column decoder. Let's move this. Let's move this. Yeah. Let's move. Okay. Okay. So one is done. Next. So I have to copy these 4 times. Okay. Remember, I have to copy this how many times? 4 times, because I want to make a 4 into 4. I want to make a 4 into 4 exponential. Remember. So here, what will happen? I want to delete this line select and this right. Okay, I was compact as possible. Okay. This is our data. I want to keep the data here as well. I want to keep the data here. Now I want to copy these as well. Fine. I want to copy this as well. Fine. So what I did, I actually copied what? I actually copied four of them. Okay, I actually now okay. My data. So at first, this will be what? Let's call it D3. Let's call it D2. Call it D1. Let's call it D0. Okay. Now line select will be same for everyone. That's why they will be common. This right selection will be common for everyone as well. Okay. Now this one will be connected with this one. This one will be connected with this one. This will be connected with this one as well. Make them look alike as well. Now this D3, go ahead and see here is D2. Go there and go here. It's D0. Go here, here as well. I don't like this. So this is our four connections. So one for one data, right? So now what I want to do, copy this. I want to copy this and make another row. Understood? See what I have done, right? I want to copy this. I want to copy this as well and make another one. 4 into 4, right? Now I want to move them a bit up, maybe, or maybe not necessary. Now these are our 4 into 4. That why 4? Because you have 4 rows and 4 columns, right? Now let's connect them together and connect it with this connect them together with the MOSFET. This MOSFET I do not like this, the extra one. The extra anything I do not like. Connected. Here, no. Problem with this one. বুঝতে পারছি? So these are all 4 externals, 4 into 4. Now let's make the lines. Make the lines. I made a mistake. This will give trouble. This will give me a lot of trouble. See? Now, oh no. It would give me a lot of trouble, okay? So be careful. Once you make any connection, if you want to remake it. And the next one, okay, there is no next one, it is also fine, right? What else we need? We have to make the we have to connect the row. So let's go to the insert and at first save this one. Save as SRAM 44, right? Now I want to select, I want to insert another schema. This is our row selection decoder. Not from there, as you can see, it's there. I want to move it from there to here. Go from there. Second connection. Come from here. Third one. From here. And last one is from here. Okay. Understood? Everyone? Hello.
Yes, sir, understand.
Yes, sir.
Now, let's make it a bit small. Now, we want to save some. Let's say we want to save some data. What do we want to save? Let's see these. Okay. We want to save something like this. Let's say we want to save the data like this. 1 0 1 0 1 1 1 0 1 0 0 1 and 0 1 1 1. We want to save these 4 data. We want to save these 4 data where? In our SRAM. Okay, got my point? Understood, everyone? We want to save these 4 data in our SRAM. So let's go and save. At first, what? At first, line select? No. At first, you have to configure the. Is there any problem? Yes. No problem. Oh, yeah, there is a problem. As you can see, there is a. Okay, can you see that? There's an open circuit. Be very careful about this. Okay. At first, what we have to configure our data. Remember, so first is what? First what? First data. Remember. So let's give the data at first 1 0 1 0, right? 1 0 1 0. So this is 1, this is 0, this is 1, this is 0. Next what? Next we have select the line. There is a problem. There is a problem means the line be cannot be what? Line select cannot be. Yeah, there's a problem. Oh no, no problem, no problem. So it will go at once. So 1 0 1 0. That's fine. Okay, no problem. So what I have to do again? At first, you have to what? At first, what you have to do? You have to give data. Then you have to select the right. Then you have to select the row. Then you have to select the line. Okay, let's check this at first data, then right, then row, then what? Line. Understood, everyone? Or you can take the row, this row form. If you want to change it, you can bring them before right. You can change them. You can do them before right. Understood? You can change the row first, then you can do the right. But remember, data will be first, row second, right third, line select will be the last. So 1 0 1 0. At first we have to select the 1 0 1 0. So 1 0 1 0. Then you have to do what? You have to select the row already selected. Then you have to give the right. Then you have to give the line. Okay. Once they are done, as you can see, this is gray color. This is gray. This is gray, right? All of them are gray. Can you see that?
Yes, sir, we see.
All of them are gray. But this first line, it is 1, it is 0. It is 0 because it is blue, it is red, it is blue, it is red. Got my point, everyone? So that means the first row is already used, right? Using the data. So now the second row. Second row was what? What was our data? 1 1 1 0, right? 1 1 1 0. Now I want to deselect the line. No line will be there. No right will be there. No right. All of now change the data. What? 1 1 1 0. Now change the row. Row will be 0 1. Next, click right. Next, click line select. As you can see, it is 1 1 1 0, right? It is not affecting the other rows because the row selection is here now. It is not affecting rows. Other rows are fine. Now what? Now deselect the line, deselect the right, change the row now, okay, or change the data now. Next data is what? Next data is 1001. So 1001. Click row now, 10. Click right now, click line select now. As you can see, it is 1001. Fine. Now deselect the line, deselect the right, or change the data 0111. The last one, right? The last data is 0111. Now select what? Row now, 1 1. Deselect the right. Change the row as well. Your data is already saved. As you can see, this one is red. That means it is 1. This is 0. This is 1. This is 1 1 1 0. This one is what? 1 0 0. This one is what? I say, right?
Yes, sir.
Yes, sir.
So this is your SRAM. So now if you change the data, doesn't matter. If you change the row, doesn't matter. Your data is fixed. Can you see that? Right? So your data will remain like that. How long your data will remain like that? Anyone? How long that your data will remain like that? Your data will remain like that until you change the data. Sorry, there will be an end, right? Change the data or delete the data or what? Switch off the power, right? Switched off. So if you change the data, changed, that will be gone. If you delete the data, that will be gone. If you will be gone because it is RAM,
Yes, sir.
right? Because it is RAM. So if I switch off, you can see all of them are gray now. No one, no zero. Can you see that?
Yes, sir. We see.
This is your SRAM.
Yes, sir. We
So
can
all
make it,
of you
sir.
can make it. So if I ask you, this is very easy. This is not very tough. There is a problem here as well. What is the problem? Maybe after some time. Off. Okay.
Sir.
Yeah.
Sir, what happened? That will become a five input or five or six maybe around that.
Okay. If you want to make more, what will
Yes, sir.
happen?
Yeah.
See, this is the row selection decoder. This part, that means this section, you have to copy them. You have to make 5 or 6 or 7 or 8. Now then you use row selection
Yes,
as
sir.
well. Okay. Now this circuit will be more bigger. Okay.
Yes, sir.
So you know this circuit. This circuit is the decoder. You have learned these from your digital
Yes,
electronics.
sir.
This
Yes.
was decoder.
Yes, sir.
Okay. So you have to. This is actually 2 into 4 decoder. You have to use 3 into 8 decoder, or 4 into 16 decoder, or 5 into 32 decoder, or 6 into 64 decoder. Something like that. If you have more, and more.
Yes, sir. I
Understood?
understand.
হ্যালো স্যার
Yeah, follow.
স্যার এখানে কি স্যার এই যে স্যার সার্কিট সাইট ডাটা সাইটটা থেকে সার্কিট স্টেট
হ্যাঁ
আছে
হ্যাঁ আমার এখানে ডাটা চারটা ছিল দেখি সার্কিট চারটাই
আর স্যার ওটা কি
বুঝছো?
আলাদা আলাদা ভাবে স্যার সেভ করতে হবে স্যার
কোনটা?
ডাটাগুলো স্যার
হ্যাঁ ডাটা সবসময় আলাদা সেভ করতে হয় বুঝতে পারছো? আর এটা হচ্ছে 4 into 4 4 into 4 মানে কি? এটা আসলে এই যে এরকম এই র্যামটা আসলে এরকম ছিল। দিস ওয়াজ অ্যাকচুয়ালি 4 into 4 4 into 4 means it has 4 what? You have less slot, that means you have less RAM. Understood everyone?
Yes, sir. I understand.
Now, can you make SRAM?
Yes, sir.
So there will be no lab report for this one, but I want a design. So all of you design your SRAM. All of you design your SRAM and upload your screenshot today. Okay, like this. F5. No. F5. Then you select 1010. Then you select right. Then select. Okay. You select then 1110 or 1001, something like that. Then you change the row. Then you write deselect 1110. Change the row, right line select. Then maybe 0111, right line select. Okay. Now unclick everything. Unclick everything. Now track this. Remember, this I do not need. Hide it somewhere. Take the screenshot like this from here. Go here. Okay, I do not need this up to this. Take the screenshot, save it, and upload the screenshot in the Google Classroom today. Okay, I will make one what? I will make one SRAM. What is that called? SRAM, so that you can upload your SRAM. I will make one assignment. Okay, everyone.
Yes, sir. Understand, sir.
Do not copy or do not make other people's SRAM, or do not upload other people's SRAM. Okay, everyone. So this will be one of your assignment, small assignment. Just SRAM. No writing required. Just SRAM. Keep the data here. You can see the data is there. 1 1 0 0 0 1 1 something like that. So data is there. You take the screenshot and upload. বাঙালি যারা আছো বুঝতে পারছো? Muraz, did you understood? Did you understand?
Yes, sir. Yes, sir.
Shoaib, you understand? Saidul, বুঝতে পারছো কি বলছি?
Yes, sir. Understand.
Yes, sir.
What's the data?
Huh? Data is your wish, whatever you want.
Okay, sir.
Okay.
We are facing some problem regarding the Google Classroom, sir. Still, we cannot upload the lab report, 3 lab report.
You couldn't upload, right?
Sir. Yes, sir. Because of sir, when I'm inserting something in the Google Classroom, he say so you can contact your teacher. There is some problem in your lab. So Google Classroom, sir.
Maybe my storage is off, right?
Sir, the program, sir.
Maybe the storage problem. So I will delete all the videos from Power System Analysis. Do you have all the videos Power System Analysis? You have downloaded all of those?
Yes, sir.
We do it.
So you keep it, okay? If I need someday, I will ask from you so that you can come and you can give those what? Give those what is that called? Keep those videos to me. So I will delete those videos today. I will delete all those videos today, and you can upload them right then. Okay? Maybe there is a storage problem. Okay, everyone?
Okay, sir.
Okay. Abdullah, people say me.
Already, sir.
Yeah? ঠিক আছে, okay. Ibrahim, understood?
স্যার
আচ্ছা, আব্দুল কাদের একটু পরে বলো, হ্যাঁ? একটু দাঁড়াও। জাহিদুল, কামার, ফাতা, তাকলাইন, বুঝতে পারছো?
জি স্যার
শাহিদ শিদে, roll 16, understood?
ইয়েস স্যার
আব্দুল কাদের, বলো কি প্রবলেম তোমার?
স্যার আমি ল্যাব রিপোর্টটা আপলোড করতে পারছি না স্যার, আমার সবটুকু করা ছিল, ল্যাপটপটা সমস্যার কারণে সম্পূর্ণ চেক করে ফেলছি। আমার নতুন করে করতে হচ্ছে, একটু সময় নিতে চাইছিলাম স্যার, এর জন্য।
সময় নাও, সমস্যা নেই, ঠিক আছে, সময় নাও।
জি স্যার।
আর একটা জিনিস মনে রাখবো, সময়টা হচ্ছে যে মেইনটেইন ইওর ওন গুগল ড্রাইভ। ওকে, সবসময় মনে রাখবা কি, সবসময় হচ্ছে যে এই সমস্ত ক্লাস অ্যাসাইনমেন্ট যেগুলো আছে না, এগুলো তুমি হচ্ছে তোমার গুগল অ্যাকাউন্ট, গুগল ড্রাইভে আপলোড। যদি কোনো কারণে আমার পিসিতে সমস্যা করে, তখন আমি ওখান থেকে দিতে পারি। বুঝছো? এখন থেকে এটা মেইনটেইন করবা, সেটা হচ্ছে গুগল ক্লাসরুম মেইনটেইন করবে, গুগল ক্লাসরুম না, গুগল ড্রাইভ মেইনটেইন করবে।